Guys, so last time we solved the two sum problem where we have integer array and a target, and we have to find the indices which sums up to the target. So next we're going to solve this subarray sum equals k problem recommended by Leetcode. Let's go to the problem. So the problem is we're given a integer array and a number k, and then we have to find how many continuous subarrays are there which sum is equals to k. So for example 1 1 1. So in this case, for the sum to be 2, these two can be included to add up to 2, or these two can be included to add up to 2. So there are two subarrays with sum up to 2, so it will be 2. 1 2 3, and the sum is 3. So this is 1 and this is another one which sums up to 3. So there are two solutions, right? So let's give a look at the constraints. The length is starts from 1 and is maybe equals to 2 to the power 2 into 10 to the power 4. The value itself, the integers in this array, could be somewhere between minus 1000 to 1000 inclusive. Okay, and the k could be, the sum could be from minus 10 to the power 7 to 10 to the power 7 inclusive. So take some time to think about this problem. I mean, I'll go through the thought process somehow. I'll try to do that. But this is a really complex problem, and it's a medium complexity problem. Uh, so, I mean, let's think about the solution. The very obvious solution would be to go through all the possible subarrays, calculate the sum, and then check if that is equals to k. If it is, and then increase the counter, and then return the counter. But that will be too uh, slow. That will be too slow. It would not be optimized at all, right? So think about some of the other problems that we could have. So let's say we have uh, so the array could have 0, array could have negative numbers. So that means if 1 minus 1 0, and the sum that we're trying to find is 0, in this case this is one solution and the whole array is one solution, and this itself is another solution. Three solutions should be there. So this will create some complexity, right? Yeah. So let's see. If we have numbers a b c d e f, right? And then we're trying to find some number k, and k could be anything. A plus b could be equals to k, a plus b plus c plus d could be equals to k, right? And c plus d plus e could be equals to k. So in this case, how do we find all these subarrays? Another solution is we go on adding the numbers from left to right, right? So we have to find all the sums array, I mean the sum of the array, and then if we find it, we can increase the counter. Again, we can decrease the sum from the left to right, and then it will give us the remaining array sum, and that could be equals to the value of k, which is in this scenario. So think about all of those scenarios, how you could optimize that. Let's go to the solution. So one easy solution that I could think of is we declare two variables, count equals to 0, sum equals to 0, and then for I equals to 0, I is less than the length I plus plus. What we could do is we could sum plus equals to nums I. If sum equals to k, that means plus plus, right? Because the scenario that we're considering right now is this scenario where we have number a comma b comma c comma d comma e, and then we are searching for k, and let's say some subarray which starts from start a plus b plus c is equals to k. In this scenario, this will give us the solution: sum equals to k, count plus. And let's say if b plus c is equals to k, right? So to find this scenario, what we have to do is we have to subtract the cumulative sum that starts from the very beginning, right? So we can have another for loop here, and we can declare another variable sum2 equals to 0 for j equals to 0, j is less than I, j plus plus, sum2 plus equals to nums j if sum minus sum2 k plus plus, right? So for each number, it's looping again from beginning to that value of I and calculating if there are any subarray in between I and j that have the same sum. And then finally we return count. But this the complexity of this solution would be n square, and I think it will work if I'm not forgetting any edge cases. Yeah, it worked, but again, this is a not so much optimized solution because its runtime complexity still is n square. What we can do, so let's analyze the nature of this solution. So the way we are solving this problem is, let's say we have an array of a b c d e. What we're doing is we're calculating the sum from left to right, uh, a plus b, a plus b plus c, and then we're checking if it is equals to k. If it is k, we're incrementing the counter, and again, to let's say we are here at a plus b plus c plus d, and we are also subtracting the sum from left to right, which is a plus b plus c plus d minus a, which is equals to b plus c plus d. If that is equals to k, we're incrementing the counter again here. So we're going on doing this a lot of times, which is n square. So if we analyze properly, the sum between two indices is always something. To find the sum between uh, this index and this index, if we find the cumulative sum of up to d and then subtract it by the cumulative sum up to a, we get the medium uh, sum, right? So what if we memorize this instead of calculating it again and again, because here we are calculating the sum again and again and again, and that's why the complexity is increasing. What if we memorize this and use that to solve the problem? So I'm going to go with my second approach. For the second approach, what I'm going to do is, I still need a counter and a sum, but I am going to memorize the sum in a map. Integer new, and in this map I'm going to store the sum as well as the number of times the sum has occurred, because the negative numbers are also possible in this example, right? As you have seen, what if some array up to I is equals to k, and then again somewhere in between there is a subarray which has a sum of 0, then next number occurs, it will still be the same. The count should still increase. So for let's see, that I'm putting 0 as 1. Occurrence of 0 is 1 right now, because if we find the sum and then we have to search for the sum minus k, will eventually start searching for 0, so we have to increment the count. I if okay, so what I can do is equals to m dot get r default minus k 0. So it's searching for a sum minus k, which if already occurred, then the adding the current number, we have found a subarray with sums equals to k. And then finally what we're going to do is dot put sum default, it will be sum. We're incrementing the sums, the occurrence of sum by 1. And now if we check the solution passes, if we submit it again, it's 19 seconds. So this is n square solution and this is n solution. And this is a very important problem. A lot of different problems are asked which can be solved using this prefix sum technique, and it's really helpful if even if you are participating in the contest which occurs every week. This solution, this algorithm is really important to solve a lot of problems. So hope you guys spend some time trying to figure out what's exactly going on here, how this prefix sum is working, how we can use this to solve different problems. And this is one of the very important algorithm for your interview preparation. Thank you guys. See you guys next week.